Bismillahirrahmanirrahim. Assalamu alaikum and a very good morning. Welcome to this workshop on statistical analysis with Jamovi. My name is Jawad Hashim. I'm an associate professor in the Department of Family Medicine at the College of Medicine and Health Sciences at United Arab Emirates University. And it's my pleasure to host this conference. I'd like to have active participation. Please do download the practice file that I have sent in the message box and open it in Jamovi using the import option. So let's get started. I've divided this workshop into 4 parts: introduction, data variables, basic descriptive statistics, and then finally statistical tests. So this kind of follows the workflow in statistical data analysis in research studies. And I hope you will find this intuitive and useful. So in the first part, in the introduction, we will discuss what is Jamovi, the Jamovi user interface, its various menus and tabs, and then the Jamovi add-on modules that extend the functionality of Jamovi. Jamovi is fairly new statistical software. It's a program that can be installed on Windows, Mac, as well as Linux. And I think the distinguishing feature is that it is easy to use. It's um, fairly intuitive. The menus and the options are easy to recognize. So you really don't need a lot of training. So I think it will make my job easier. And as you will see in this demo, that all the options are easy to access. And you can do quite a lot. So the package itself is based on R statistical language. So you have the option of either learning R language or using Jamovi. And Jamovi being mouse-based point and click, it's so much more easier than learning a new language, a programming language like R. Of course, if you want to use R syntax, you can use it in Jamovi. So Jamovi has a module that you can use, install, and then you can type in R syntax and Jamovi will do your analysis and display it. So it's a great way to learn R language if that's your goal. Or if you want to do a quick data analysis on your study data, then I think Jamovi is the way to go. It includes, full range of analysis, not just the basics, but yes, from fairly advanced statistical methods, including mixed regression, linear models. So, there is no limit because new modules keep getting developed. It has a statistical spreadsheet, so you can, add your data, compute new variables, etc. It's great for teaching, and it has an active community, so there's lots of learning and teaching resources. Plus, it has some its own unique features, including the ability to backtrack in your analyses, and that I'll show that to you. So this is a screenshot of Jamovi, some of the Jamovi modules, and I'll show you how to install that. So Jamovi is definitely extendable. And if you're interested, you can do your own programming and learn how to code and add new modules in Jamovi using the R language. And here's an example of using the RJ editor in Jamovi. So instead of using your mouse to point and click, you can type in the command and you will get the output. So here somebody is doing a descriptive analysis on data set for the first 3 variables. And then instead of using going to the different menus and clicking, some of the professional statisticians, they would prefer to do this because it's much faster. It all depends on how much analysis you do on a day-to-day basis. If you're doing occasional analysis, I would recommend that you stick with using your mouse and the Windows interface. If you're a professional statistician and looking to, use the full range of commands in R, then certainly using the RJ editor is the way to go. Okay, so let me show you the Jamovi interface. So here is Jamovi. I hope you can see it on your screen. It has a fairly clean layout. It's not too cluttered, and I have imported a data set in it. I will go over the different options and menus. So here you can see at the top is the Jamovi file name that has been opened. The file name is sample data file 1, and I have sent a link of this file to you in the message box. The three horizontal lines here is actually the file menu. You could call it the options menu. And if you click on it, you have different options. You can create a new blank spreadsheet. You can open a file that has already in the Jamovi format. So if you were working on a file previously, you could open it over here, or you could import. And Jamovi supports a fairly wide range of import options. So if you look at some of the formats that Jamovi can import and convert it into its own format include Excel, SPSS, Stata, SAS, and even R data files. So you're not really limited by the kind of data that has been sent to you for analysis. Um, Similarly, if you want to export, you can export it in a fairly wide variety of formats, including SPSS, Stata, SAS, as well as HTML. So, you can, after analysis, when you export it, and when you export it, Jamovi exports your analysis as well as data in a single file. So both the output as well as the data are included in the file. And if you click on this back arrow, you go back to the main Jamovi interface, and this is the home page with the data tab open. The data tab has a standard uh, ribbon for data entry or data transformation. And I will go over some of these. And then we have the analysis tab where you do the statistical analysis, and the edit tab, which allows you to edit some of the results and change the text formatting. So in the data tab, you can paste data directly if you copy from Excel. If you click on setup, it will take you to different parameters for each variable. So if you look at each variable, you can change the different parameters. What is the measure type, data type? How are the missing values coded? So this is called the setup, and you can close the setup bar by clicking on this up arrow. And you can access it again by clicking on setup. Compute and transform we'll discuss later on in the next section. They allow you to compute a new variable or transform an existing variable into, for example, groups. You can add a new variable over here, although I would recommend that it's better to add variables in your original spreadsheet, maybe in Excel, but you can certainly add a new variable. You can insert a computed variable or a transformed variable. You can do it right at the position where your current selection is, or you can append it after the last variable in your data set. And then you can filter. Filter is like select cases in SPSS. So if you want to only say analyze data for the male participants or data for only for the female participants, you could use filter. And then the rest of the data will be ignored in the analysis. So it's useful to do this. And the good thing is in Jamovi, filter works dynamically. So if you apply a filter, you can see how data changes in the output. So if you have a table showing means, if you select a filter for only males, then the means will change to means for males only. And that really allows you to see the effect of different analyses on different subsets of data. Add is similar, but you here you're adding data rather than variables. And you can insert a row of data, or you can append a row of data um, below the last row. Um, the the analyses tab includes basic descriptive analysis using exploration menu here, and you can see the descriptives option. You can do t-test, Anova, regression, frequencies, factor analysis, and linear models. So as you add more modules, they will start appearing in this area. And for example, if you've just installed Jamovi, you may not see the linear models option because I've installed this as a new module. And let me show it's fairly easy to install a new module. Just click on the plus sign here. And you can see that I have already installed 4 or 5 modules. You can access the Jamovi library with just one click. And you can see Jamovi developers have already ported many of the R modules into Jamovi. So most of these are existing R modules, and instead of you learning their specific commands and parameters, now you can just use your mouse to point and click and drag different variables. Instead of using the text-based syntax, you can use menus to make your choices. So a fairly wide range of modules, and it's again fairly easy to install um, uh, new modules. Let me show you just with the one click. If you click on install, it will start installing, and then you just wait for the download to complete. So there is no other commands to perform. And this is, I think, again, very easy and simplified installation procedure as compared to installing modules for other programs, including SPSS and R. Um, if you look at the 3 dots here in the top right corner, these are the settings options for Jamovi. So if you click on it, a panel opens up from the right side, and you can change the zoom level um, depending on your level of comfort and age. You can set the number format in terms of number of significant figures, or you can set it to decimal places. I would keep it at 3 significant figures, which is the default. The p-value format is again through 3 decimal places, which is good because sometimes in SPSS you get many decimal places, and if you just report that in your paper, it will not look nice. So you want to round the p-values to just 3 decimal places. Otherwise, it looks amateurish and unprofessional. References is basically adding the references or the original article from which the analysis is based on. I generally keep it hidden, but if you want to see which mathematical the source paper from which that special analysis is based on, you can make the references visible. Syntax mode shows you R commands as you apply your analyses. This is a great way to learn R language. So you can, after each command, you will see, you use your mouse to do the commands, and then you will see what R syntax is for that command. So again, a great learning tool. You can change the color of the plots as well as the palettes. Um, so those things, you can, for any graphs or charts that you make, you can change the color theme. And then there's a basic screen capture tool, which will capture the current screen that is showing for Jamovi, and then save it to My Documents. And then you can use that maybe in your presentations or your documentation. But I would not recommend using this to import charts. Okay, so we've covered the basic interface of Jamovi. You can see a good thing feature is at the bottom, there is a status bar, which shows that one filter has been applied. So you want to make sure that if there is a filter that is applied, it is not sub-selecting anything. I'll just delete this filter for now. So now you can see there are no filters that have been applied, and you have to be careful. If you accidentally apply a filter, you will be only analyzing a subset of your data and not the entire data set. Okay, moving on to the next part, and we will discuss data variables. And in this part, we will discuss variable types in Jamovi. We'll try to compute a variable. We will group variables. For example, if you have age as a variable, you can group age into different ranges. And then you can select a subset of data using the filter feature. For those of you who are just joining, we've just covered a basic overview of Jamovi, so you're joining not too late. And we also have a short vacation. So we will be taking a brief vacation to Maldives, and I'll be sharing some of my vacation photos with you. So stay tuned. There are four variable types in Jamovi: nominal, ordinal, continuous, and ID. Um, nominal and ordinal may be called categorical or discrete variables because they can only take certain values. So a nominal has no numeric value and no order or hierarchy. Examples include gender, brand, color, etc. So you cannot produce an order here. There is no value is greater or higher than another value. Ordinal, on the other hand, does have an order or a sequence, and examples are things like Likert rating scales, job ranks, military ranks, etc. And then you have continuous variables, sometimes called scale variables, I think in SPSS, or interval variables. And examples include age, weight, temperature, etc. And finally, you have ID variables in Jamovi. These are variables that are just used for identification and should not be included in any analysis. So in a way, it kind of saves Jamovi from analyzing these identifiers. And remember that in nominal, you can only calculate the mode, while in ordinal, you can also calculate the median, whereas in continuous variables, you can calculate all three measures of central tendency. Okay, let me switch to Jamovi. So here I have imported the practice file, and again, the practice file is available through the chat message box. Please download it and open it in Jamovi using the import option because it is in Excel format, and Jamovi can easily import an Excel file. So here are the variables, and you can see there's a serial number. So this is like a hypothetical study in which there were two groups, the experimental and control groups, and then you had an initial score and then a final score. So you want to know if the intervention, especially the subjects in the experimental group, did they do better than the subjects in the control group on their final score? And you want to just report the statistical analysis for that. So as I mentioned in my previous workshop, you want to remove any kind of identifying variables. So I'll delete variables. As easy as simply right-clicking on it and then clicking delete variable. And it asks for confirmation, and I will do that. As I mentioned earlier, for each variable, there is a setup option. So I will click setup, and I will change this type to ID, because remember, ID is not analyzed. This is just a serial number for identifying each row or person or participant. So I'll change this to ID. Uh, Gender is already coded as nominal, so that is correct, as well as group. Age, age is a continuous variable, so it should be changed to continuous. Even though in our data we don't have any decimal values, but age is definitely considered a continuous variable. The IELTS score is also a continuous variable and has been coded as such. Uh, uh, then parents' education, and this is the years of education of the parents of the subject, and this is actually a continuous variable as well. So I will change the type to continuous. Initial score is also a continuous variable, so I will change it to continuous. And then final score is also a continuous variable, so I'll change it to continuous. The subject school, whether private or public, is a nominal variable, so I'll keep it as nominal. Notice that there are two levels here. I can change the levels. I can change the order of the levels also. You can also code levels as 0 and 1. So you can add what's called a transform. And then, you could, and if the data was entered as 0, it will show as private. And if it was entered as 1, then it will show as public. So for that, you would use the transform option to do that. Okay, so let's compute a variable. We will create a new variable by clicking compute. And notice it adds a new column here, the J column. We will give it a nice name for us to remember. So I'll call it Student Success Index. And you can add a further description. So a predictive variable computed to indicate, likelihood of success after graduate studies. So, you can have a long description. You can even add some notes here. It expands. So we need to add a formula how this will be computed. And I'm going to compute it based on, say, two variables, mean of the IELTS score and, say, the final score. So I click on this formula option here, and I have a drop-down box which shows me a range of mathematical functions, as well as statistical functions such as maximum. And if you click on each function, it will tell you what the function does. It returns a mean of a set of numbers. What is the format? Whether there are commas and any optional parameters towards the end. So I want the mean of two variables. So I'm going to click this, double click on it. So I've got the mean command entered here, as well as the parentheses. Now I need to select my two variables, and I want to use IELTS. So I'll double click IELTS and then enter a comma, and then enter another variable such as final score, double click it, and that's it. So I press enter, and you see I have a new variable called the student success score. And already it has the values entered. And notice that it has a black circle here that shows that it is a computed variable. Okay, now I want to show you how to bin or group variables. For example, if you have age as a very continuous variable, you may want to bin it, say, into children, adults, and elderly. Or different age groups, say 0 to 10, 10 to 20, 21 to 30, etc. So we'll continue with this same variable. I'm going to select the variable that I want to transform or bin or group, and then click on the transform button here on the top. So it's created a copy of the variable because we're going to use this variable and transform it into a new variable. I'm going to change the name, and let's call it um, give it a name such as uh, admit decision. So, and again, I'm going to type some description here based on student success index, divide into two groups for admission policy. So again, this is just hypothetical. Now I need to add a transform. So using a transform, currently the transform is set as none. So I will create a new transform. And again, this is, you can have as many different transform options. You can change them. So I'll add a description to this transform one. I'll call it group student success index into two groups. Okay, so let's add a recode condition. A recode condition is what tells Jamovi in how to divide this or change this variable into a new variable. So as you can see, the student success index is intact. That column is untouched. We have a new variable column that we are working on. And we will again click on the function button. And again, it shows you different options, including mathematical, statistical, reference, and miscellaneous, as well as some ways to generate numbers for simulation. So the source is just the source variable, which in our case is the student success index. And here I would like to change the source if it's like more than, say, if we just look eyeballing it here, I'll say let's more than 20, more than 30, I would say. So I can also use some programming variables, so logical functions such as if. So I'll just double click if, and if source is let's say more than 40. Then again, you can see that the if syntax is expression, comma, returns value, or the else value is if the expression is false. So if this expression is true, then it should return, let's say, return a value admit to PhD program. And if it's a false value, then we will say refer for internship. So I'll close it and press enter. And you can see that there is an error here. It says red. And looking closely, you can see that this value is a text character. And if you, it should either be a variable itself, or it should be a string. So I'll add quotation marks around it to make it into a string. And hopefully it should work now. So that's one way to recode, and you can see that this new transformed variable has been recoded. So values that are less than 30 are coded as refer for internship. Anything more than 40 is coded as admit to PhD. So that's one way to transform a variable. Of course, there are lots of different functions, including mathematical, such as log transform. Sometimes if your if your values are showing a nonlinear graph, you may want to transform that using the log function. So we have the natural log as well as the log base 10. Another point I want to tell you quickly is that if you want to check for equality, you need to use double equal to signs, not just a single, and that is common in C-type languages. So this covers showing how we've been able to compute a new variable, and then we using the mean function, and then we transformed it into two groups using a transform. And in the transform, we use a simple if command to generate two groups. Of course, you can generate multiple groups by using multiple recode conditions. So if source is equal to, say, you can say 49, then you could say, provide scholarship. So, you can use a lot of different criterias and have multiple recode conditions in a single transform. For example, in an age transform, you could say, if 10 to 20, use this label. If 20 to 30, and you provide another text label. So these are different ways of adding recode conditions to the transform. Okay, so let me just do a transfer for age groups. I'll select the age variable, and then I'm going to transform this into age groups. So again, it has renamed this as age 2. I will give it a better name, age groups. And then we call it age grouped into discrete age ranges. And just a quick word of caution, transforming a continuous variable into discrete ranges, into, say, a nominal variable, you lose information. So this is not recommended for analysis. If you want to analyze age, it is better to keep its values intact because it has more information than age transformed into age groups, because each person or each individual has its own accurate age. Whereas when you group it, you kind of lump them together and you lose information and you lose power. So you may not be able to detect a difference, and you may get a p-value that is non-significant. Whereas if you analyze it by ages itself, you get more power. And the same goes for data collection. If you're collecting data in a study, better to ask for exact age than for age ranges. However, respondents are unlikely to provide sensitive information such as age or income for the exact value. So you are unfortunately sometimes forced to request people to give them the income range or age group. And so it's a trade-off. But if you can get the actual value, it's always better and more powerful. So when do we group it? I would only recommend grouping it for displaying it in the table, because for visualization and tables, age groups are easier to understand than mean and standard deviation. So if you have age groups presented in a table or in a graph, readers of your article are going to find it more easier to understand, as opposed to just giving them the age mean and standard deviation. So with that caveat, let's go ahead and transform this now. So we're going to create a new transform, because remember, transform 1 was for student success index. We need a new transform, and this is our transform 2, and we'll call it for age grouping. So here our source variable is age. So I'm going to add a function. Uh, you can just, instead of using function, you can just directly type equal to, so two equal to signs. Or rather, actually, this would be less than, because our first one would be just less than. And here, in this data set, the age range is actually fairly narrow, so I'll have to be a bit creative. And let's say less than or equal to 24. Then your label is, sorry, I'll have to add an if statement here. And usually you want to add a descriptive less than or equal to 24 years. Okay, and then add another recode condition if source is more than 24. You'll call it older than 24. Okay, so now you can see we have two groups and using two recode conditions, we have been able to generate two groups in the age range. And if you use, you can certainly add more recode conditions for each age group as needed. And this way you can transform age into age groups. So we've covered computing new variables using a mathematical function, and then using the transform function to do grouping. Of course, transform, you can use it to do other things, including transformation, mathematical transformations. Okay, moving on to the next part, basic descriptive statistics with the Jamovi. In this part, we will discuss how to obtain the mean and standard deviation of a variable. So back to Jamovi, and this time now I'm going to click on Analysis tab, and then this Exploration, and then Descriptive. So click on Descriptives. I'm going to hide the data part, so you just have the descriptives. Again, it's from Exploration, and then the first option, Descriptives. So I will add, let's start with age. And you can see it does a live output. So you have 12 participants. There are no missing values. The mean was 24.5 years. Median is 24.5 also, and standard deviation is 1.24. The youngest participant was 23 years old, and the oldest participant was 27 years old. So this here, with simple one command, you get your mean and standard deviation from the descriptives. Similarly, you can add more variables to it. Your IELTS score, the initial score at the baseline of the study, the final score, and the new student success index, which was the mean of the IELTS and the final score. So all these variables have been analyzed, and you can split them by, say, for example, the group. So here again, you can see Jamovi provides you some visual cues. In the split by box, you can only add a discrete variable. So if I try to add this continuous variable, patient's education, into the split by box, it kind of flashes that it has to be a discrete variable. So I'll add the group. And now you can see that each variable has now been broken down into different groups. And you can look at, say, for example, the final score, mean score was 76 in the experimental group, whereas the mean score was 52 in the control group. So boys and girls, what do you do if you see a result like this? If your experimental group had a higher mean compared to the control group, it's time to celebrate. You know, your experiment was a success. At least you have a signal that you know, your experiment seemed to work. This is a great time, and you know, you want to just step outside, call your mom, say a prayer, and you know, have a small party, because this is what you're looking for. Okay, and then if you want to remove the split by, just click on this arrow here, and we are back. You can remove each variable, and you get a blank table. Let's see what happens if we enter a variable that is discrete. You don't get much descriptive data, but what you can do is click on the frequency table, and you can see here that there were 6 experimental counts and 6 control counts. You can do plots. So histogram, this would of course be a bar plot because it is a discrete variable, and you can see both the groups have 6 numbers each. And I'll do one for gender. So again, you can your study sample had both 6 male and 6 female participants. Of course, you can do a lot more with continuous variables. So let's try some continuous variables. IL score. And let's now, we don't need frequency tables for this because these are continuous variable. Notice we have a range of options for different descriptive measures, including the sample size, the missing. You can uncheck it to make the table smaller. If you're not interested in the mean, you can remove that. You can remove the minimum and maximum. But again, I'd like to look at the minimum and maximum because it tells me if there are any outliers or if there has been any data entry errors. You can look for the mode, and you can see here that this IL score has more than one mode. You can have the total. Of course, it's not very meaningful here right now. You can also generate quartiles. So you can divide into 4 equal groups, and it will generate the 25th, 50th, and 75th percentile. You can calculate the range, which is the smallest to the largest, and you can calculate interquartile ranges also. You can also check for skewness. Skewness is whether the distribution is skewed to one side or the other. And for that, we can take a look at the histogram. And you can see you get nice histograms immediately. And if you add the density line, this is a nice feature in Jamovi. You can see the shape of the curve. So this is fairly symmetric. This is a more of a flat curve. Let me add a couple more variables. And you can see here that the initial score has, again, this is more skewed to the right side. And here you can see for the initial score, the skewness is high, it's 0.8. So skewness shows the lack of symmetry. If it is 0, then it is a symmetrical distribution. Um, so this 0.8 shows it is close to 0, but it is skewed to one side. Whereas the other values like the IL score is more symmetrical, it's closer to 0. I don't use kurtosis. Kurtosis shows how flat or pointed a curve is. Um, it's not used much. Normality test is the Shapiro-Wilkinson statistic, and it gives you a p-value also. If the p-value is less than 0.05, then it is likely that this distribution is not normal. It is deviating from normal. And if you have a small sample, less than 20 observations, then you may be better off using a non-parametric test rather than parametric tests. You can also check for normality using the QQ plots. So here you can see the QQ plot is moving away from the line. So it is slightly normal, but it is skewed to one side. This one is again fairly flat, so you can see that the QQ plot is not following the central diagonal line. If the dots were plotting on the central diagonal line, then you would be more comfortable that this is closer to normal. Here again, this is slightly closer to the normal, and you can see the line plot has a central peak and is falling on both sides. So the QQ plot is useful to check for normality. Another good plot that I like here is the box plot, which gives you kind of the spread. The central line is the median, and the upper line is the 75th percentile. The lower line is the 25th percentile. It gives you an outlier. So this is good for looking for any outliers. Another plot that I like is the data plot, which is the jitter dots. So it shows the dots scattered along a single axis. Again, gives you a visual look at how spread the data is. You can have the dots on a single line, so they're stacked, or you can have them jittered, kind of scattered around to give you a density. Again, very useful ways of visualizing, and certainly this should be your first step in before data analysis to look at your data. So as we covered, we looked at central tendency measures such as mean, median, and mode, and then the variability measures such as standard deviation. And remember that standard deviation covers, two standard deviations cover about 95% of a normal distribution. And here's the skew measures, which was covered using the skewness statistic. And you can see that the mean is actually more sensitive to skew than the median or the mode. So as always, there's a poll. Do you hate statistics? If you want to enter your response number from 1 to 5, I'll tell you what mine is. I think more at 5, as you might imagine. I enjoy statistics. It is, I think, it has a role. You should not make a decision based on statistical analysis. It is just a guide. So your p-value, your final analyses are pointing you towards a direction rather than telling you the decision. So your analysis is of course dependent on your sample size, your study design, and also on your statistical technique. So the test that you have chosen, all that requires judgment, and there's an element of subjectivity in it. Okay, here's some vacation photos now. This is from Maldives. This was a few years ago. Nobody's wearing masks, so it's before COVID. And you need to, when you land on the main island, you have to take a small seaplane to go to the hotel or resort. And this is the resort that I stayed at. It's beautiful with a beautiful blue beach. And the nice, you can spend all day here just relaxing. Here was the view from my room, and very nice to just sit back and maybe read a book. Of course, you do snorkeling, but an interesting experience was snorkeling in the middle of the sea. So you just jump out of the boat with the snorkel, and it's black water, and you look for sharks. You actually swim towards sharks to get a closer view, or you look for manta rays. Again, it's a little bit of unnerving experience at times, but it is, again, something to be experienced. Okay, moving on to the next part, to the final part, statistical tests. This is possibly the most important part. And in this section, we will compare we will try to compare two continuous variables and then compare two discrete variables, and then compare means between two groups or means across more than two groups, such as 3 or more groups, find predictors of a continuous outcome, and then find predictors of a binary outcome. So in terms of choosing statistical tests, if you want to compare two continuous variables, it's a good idea to use correlation coefficient or Pearson correlation coefficient. You can compare two discrete variables using the chi-square test. For comparing two means, use the t-test, but if you have more than two groups, use the Anova. For predictors of a continuous outcome, if you have multiple predictors, you want to see which predictor is important, which one is not important or not influential, then you can use the linear regression. To find predictors of a binary outcome like alive or dead, admit, not admit, you would use a binary logistic regression. And to find predictors of a count outcome, like what is the number of COVID cases in different countries, you would use a Poisson regression. So just a quick review. This is correlation coefficient for different data sets using two variables. And you can see if the variables are closely correlated, as in the first graph with a correlation coefficient of 0.7, you get the dots are all clustered close to the line. Whereas if the correlation coefficient is lower, they are scattered around. And if the correlation coefficient is 0, they are scattered randomly all over the place. And the same goes for negative correlations. Just the concept that you may already be familiar with is residual plots. These are plots to check if the assumptions have been met in the data. If you have a residual plot which is randomly distributed, then you're okay. But if you see a pattern in this, like the right-handed graph, a right side graph, then you should be worried, and maybe you need to transform the data or use a different technique because the assumptions have not been met. Quick thing, if you're analyzing data, say for example, if you want to, if your hypothesis that you want to check is whether the surface of these metal bars is smooth. If you just look with your eyes, you might say, yeah, it is smooth. But if you look with a microscope, you probably will find some bumps and valleys and irregularities. So it's a matter of how closely you look. And the same applies for statistical testing. The study conclusion depends on the sample size. If I can get a p-value less than 0.05, a significant result, if I increase the sample size sufficiently. So this is not a very satisfying way to look at science. And this approach, which is called the null hypothesis testing approach, or significance testing approach, has been criticized. And this is the traditional approach that has been used over the last 20 to 50 years. and also called the frequentist approach. A different way to approach this is using the what's called the Bayesian approach, in which you make a prior estimate before the study. So for example, if you're measuring a distance and your estimate is 0.2 kilometers, you do a study and your final result based on the study findings you feel is that the estimate has now changed to 0.4 kilometers. But what if you did another study and your prior estimate was 0.5? Then based on your study findings, your estimate afterwards will be higher. So the prior estimate influences our final estimate. And that is, in summary, what's called the Bayesian approach. And Jamovi returns the Bayes factor, which is an alternative to the p-value. And now studies are starting to report Bayes factor, and you should be familiar and comfortable in interpreting the Bayes factor. So I would say a Bayes factor of more than 3 provides moderate evidence for the alternative hypothesis. So again, something to look out for and possibly report in your own studies as well. So Bayes factor is actually a ratio of the odds of the prior, the likelihood of the pre-study data or hypothesis as compared to the likelihood of the after-study hypothesis or data. Another important thing to remember is effect size. So for example, greenhouse gases, greenhouse effect has been blamed for global warming. So a lot of people, even scientists, debate the existence of global warming. And if you, that really raises 2 questions. Does global warming exist? Yes or no? And then the second question is, if it does exist, how much is it? How many degrees centigrade has the global temperature gone up, say, over the last 10 years? So those are 2 separate questions, whether something is there or not, which is, yes or no question. And that can be answered in terms of probability. And then the second question is, how big is the effect or the effect size? And the p-values tell us whether the finding is true or not. So the p-values tell us the data that we have obtained, that we have observed in our study, how likely are they due to chance? Can they be explained by chance? Is it like, and so it gives you just an indication of whether the finding is true or not. It does not tell you anything. The value, the exact value of the p-value does not tell you anything about the strength of association. Whereas effect size tells us the magnitude and strength of association. So again, you want to be a bit familiar with effect size measures. These are all effect size measures. And you should be able to interpret the effect size as small, medium, or large by looking at the number. Partial eta squared is a popular effect size in psychology and education, whereas odds ratio is a popular effect size used in clinical medicine. So I'd like you to, if you can type which effect size measured has the most intuitive values. Which one do you think has values that make sense just by looking at them? Just if you want to type in the message area, among these 5 effect size measures, which one looks the best to you? It's easy to understand. I hope my question makes sense. These again, you can see the correlation coefficient. The large effect is actually 0.5. So if you have a correlation coefficient of 0.5, that's a large effect, whereas the upper limit goes up to 1. So again, you have to remember these ranges to be able to interpret them appropriately. I'll just say I'm a bit partial because my own preference is for the e-value, which is something that I have proposed as a new effect size measure, which is easy to understand and certainly easier than partial eta squared and odds ratio. Okay, so let's move to back to Jamovi. And I'm going to remove this. You can right click and remove these analyses by just clicking on remove. So we have a blank results page. And let's start with um, correlation coefficient between two continuous variables. So let's say we want to correlate between initial score and final score. I will go to regression and then correlation matrix. And then I will say choose the two continuous variables that I would like to correlate. And here you can see that the Pearson R is 0.06. So remember from the chart, this is very close to zero. That means there is really not much correlation between um, the the two um, the two variables. Let me answer the questions towards the end. Let me add another variable now, say the IELTS score. And here you can see that the IELTS score, it does not correlate with the initial score, but it correlates very strongly, 0.9. That's a very strong correlation. And we can say that the IELTS score and the final score are strongly correlated. If you have small samples and non-normal data, you could use the Spearman, which is based on rankings. You can also show the correlation matrix. Here you can see this strong correlation between IELTS and final score with a strong linear line. Whereas the other two graphs, the dots are all scattered all over the place. And the gray shading shows the interval of uncertainty. So it's all over the place for these two graphs, whereas the correlation between final and IELTS scores are strong. And you can certainly report this value of 0.9 in your results section. Okay, so again, I'm going to now do a descriptive of two categorical variables. Um, and here we see we have two categorical variables, gender and group. And I need to analyze and possibly do a chi-squared for them. Um, so I will go to frequencies and independent samples, and it actually shows you chi-squared test of association. So in the rows, I will put in group, and in the column, I will put gender. And you can see the distribution is fairly balanced. For statistics, I want the chi-squared, and the chi-squared, the p-value is 1, so this is non-significant result. You can also do other calculations, such as the odds ratio, which is 1, which shows no association, as well as the Fisher exact test and other tests for the discrete variables. So we've compared two discrete variables. Now let's compare two groups. So for that, we will use t-test. And because we have paired sample here, individuals who had the initial and final scores will use the paired samples t-test. And we have so we have the initial and the final score, which are the paired variables. And you can see the p-value is 0.002, which is significant. So there is a significant difference between the initial and final scores. And we can look at the descriptives. So it shows that the mean score in the initial was 45, whereas in the final was 64. So that is a difference, and you can plot it and see, yeah, there's an obvious difference here. You can calculate the Bayes factor using a prior probability. So you need to give a prior probability. And here you have a Bayes factor of 21, which is, as we discussed, is far greater than 3 and indicates a significant change from the initial to the data observed. Okay, what if you have independent samples? Let's say you want to compare the age in the males and the females. So you'll put gender in the grouping variable. And here you get a non-significant result. Again, you can see the descriptives. And the descriptives show that the mean age is 24.7 in females and 24.3 in males. And they're pretty close together. And that's why you're getting a p-value that is non-significant. What if you have more than 3 groups? Then you would use an Anova. So for example, a one-way Anova. We don't have 3 groups here. So you would generally put, say, the grouping variable here, and then the dependent variable or the outcome variable over here. So let's try this with maybe the group and the final score. And again, let's do the descriptive table and plots. And you can see, yeah, it looks visually different, and the means are quite different here, 76 versus 52. And naturally, you get a p-value that is less than 0.001. It's showing that the experimental and control groups are fairly different. So you can copy the graphs, you can export them, you can copy and paste it as an image. I don't recommend using graphs from Jamovi. Again, it's a bit simplistic. I make all my graphs in Microsoft Word or Excel. I just copy the data. It takes a little bit more time, but then you have fine control over your graphs. Okay, lastly, we look at regression. So if we have one outcome variable, we'll use the linear regression under the regression button. Our outcome variable is the final score. So I'll put that as the dependent or the outcome variable. And then we have multiple input variables. So our input are things like age, IELTS score, parents' education, initial score, and of course, group, which are discrete variables. So I'll put them over in the gender. And as you notice that with each, as I add each variable, you get the table is updated. Looking at the model itself, we have an R squared of 0.993. Of course, that is excellent. Normally, we don't see that in our real studies. It's usually closer to 0.2 or 0.5. But this shows that 99% of the variation in the outcome variable is explained by these predictor variables. So which predictor variable is the most important? You look at the p-values, and we have IELTS score, which is significant, and it has an estimate or an adjusted odds ratio of 6. So this is the most influential variable. The other variables are really non-explanatory, they're non-significant. So you could remove them. So for example, age, if we remove age from the model, let's see what happens to the R squared. It decreases from 0.99 to 0.98. That's a very small decrease. I think we can live without age. Similarly, gender, if we remove gender, let's see what happens to the, again, from 0.986 to 0.985. That's really not much of a change, and you can take out. So that's how you would build a model by adding and removing variables from your linear regression. Again, fairly simple and easy to do. Of course, there's a lot of complexity here. You can add other models, variables, and compare your models. So, you can add, say, parents' education. Um, okay, so let me just remove this first. Sorry, yeah, that's, um, it doesn't seem to be adding it, but you can add different permutations and compare the different permutations as blocks. For categorical variables, you can change what is the reference. Usually the control group is the reference. And you can also do assumption checks right here. So it actually guides you on how to do your regression analysis. So again, your Shapiro-Wilk test for normality, your residual plots to see if the residuals are randomly distributed and there is no pattern to them. So here the residuals look randomly distributed, and it seems like we're not violating some of the assumptions of regression. Um, you can have additional measures of model fit, especially adjusted R squared, which is considered better than regular R squared as it penalizes you for adding too many variables to the model. Finally, if you have a binary outcome, you would use logistic regression with two outcomes. And here you have a dependent variable that should be in two outcomes only. So let's use this, say, admit decision. And now we can add the covariates such as, your final score, IELTS, and factors, which are discrete variables. So again, it kind of builds the model as you add and remove variables. So it's a nice and visual way of building your multifactorial models or multivariate analyses. Finally, you can edit your output using the Edit tab. So if you click some here you can type, conducted on preliminary data, say, and you can add notes for yourself. So this is a good way to annotate and then save. And all your data as well as your output is saved in one file. So you don't have to worry about saving the output as a separate file. If you just click save, everything is saved. So we've covered basic bivariate analysis as well as multivariate analysis in Jamovi. As you can see, it's fairly simple and intuitive. It will also give you R syntax if you're interested in just by looking at the syntax mode in the options. So to summarize the steps in statistical data analysis in your study planning, you should write down your study aims and hypotheses, which variables you're interested in correlating or finding associations. You should estimate your sample size and with the desired power of the study. You should do a data check after obtaining your data, assign appropriate variable types like we did in Jamovi. Check for any data entry errors, missing values, and outliers, mostly by visualizing the data or by looking at the minimum and maximum in the descriptives. And visually review all your variables in graphs so you can see using either the box plot or the jitter dot plot to see if there are any variable data entry errors or outliers. And then you can compute new variables and group or bin them as needed. Statistical analysis generally start with descriptives, with the mean and standard deviations, bivariate analysis, including correlations and crosstabs, with Pearson correlation and chi-squared, and then finally do multivariate analysis with the linear or logistic regression. So Jamovi includes a user guide on its website, which is fairly useful, although I've not really needed it as such. There's a free textbook available on Jamovi website. This is a little bit heavier on the mathematics side. So it all depends on how deep you want to go into the statistical theory behind each test. It comes with its own website, learnstats with jamovi.com. There are other websites such as Jamovi Guide, which provide nice step-by-step, guidance for doing statistical testing. And then there are a ton of videos on YouTube for understanding Jamovi. Again, I've not really had the need to watch them because it's so intuitive. And really, I've switched from SPSS to Jamovi for all my analyses. I haven't used SPSS for some time now. So that concludes our workshop. I hope you enjoyed it and I learned from it. Please do try out Jamovi and spread the word. It is free. And I used it with children as well in high school, and they've loved it. So thank you for watching, and I'd be glad to answer any questions.
Thank you so much, Dr. Jawad. Please, guys, if you have any questions, you can raise your hand or you can type in the chat.
Well, I think it's pretty simple and intuitive. You can't go wrong, but just by clicking and trying out different variables. So I've not had any problems in doing my analyses in Jamovi. You never really get stuck. Okay, I think if there are no questions, we can call it a day, and hope to